When the temperature outside spikes, we simply retreat to our air-conditioned cars and drive back to our air-conditioned homes. A 1.5 degrees Celsius rise in global temperatures above pre-industrial levels feels like a minor inconvenience when we easily adjust our own thermostats by much more than that every single day. This visualization shows Earth's natural carbon cycle. Every year, the planet absorbs and emits roughly 100 gigatons of carbon dioxide. The natural inputs and outputs match, keeping the system in stable equilibrium. Over the last 2 decades, our burning of fossil fuels adds an extra 42 gigatons of CO2 into this cycle every single year. Nature cannot absorb this surplus, destabilizing the system. 42 gigatons is a difficult mass to picture. If you take the heaviest cinematic version of Godzilla, weighing in at 100,000 tons, human activity pumps the equivalent mass of up to 2.1 million Godzillas into the sky annually. We know precisely where this extra carbon comes from. Living organisms maintain a steady ratio of carbon-12 and carbon-13 isotopes. Isotopes are variations of a chemical element that have the same number of protons but different numbers of neutrons. Ancient fossil fuels have been buried so long that their radioactive carbon-14 isotopes have entirely decayed away. The CO2 flooding our atmosphere today carries this exact ancient carbon-14 depleted signature. Since the Industrial Revolution, we have dumped a total of 1,900 gigatons of this carbon into the air. That massive historical buildup brings us to where we sit right now, pushing nearly 1.58 degrees Celsius of warming against critical planetary thresholds. We have already triggered a mathematical certainty fueled by an imbalanced equation we set in motion decades ago. At 1.6 degrees Celsius, we hit a hard physical limit for the Greenland ice sheets. Once we cross that line, the melting becomes self-sustaining and cannot be stopped. This diagram illustrates the planet's primary cooling mechanism, governed by the albedo effect. The albedo effect is a measure of how much sunlight a surface reflects rather than absorbs. The thick white sea ice at the poles reflects 80% of incoming solar energy back into space, while the dark ocean water absorbs 80% of that heat. Since the 1980s, 95% of the thickest, oldest, multi-year ice in the Arctic has vanished, leaving only fragmented blocks floating in a massive expanse of dark water. This creates a punishing thermodynamic loop. Less ice exposes more dark ocean. As the ocean absorbs more heat, the surrounding water warms up, and the remaining ice melts even faster. This collapse happens with violent speed. In Antarctica, the Larsen B ice shelf underwent rapid cycles of surface melting and refreezing. The fluctuating temperatures cracked and shattered a massive section of the shelf into pieces in just 3 weeks. Crossing the 1.6 degree threshold actively breaks the physical mirror that protects the Earth from overheating. If we push the average global temperature up to 2.0 degrees, the physics of the atmosphere shift. For every single degree of warming, the air holds 7% more water vapor. That supercharged, moisture-heavy atmosphere creates wildly volatile extremes. At 2 degrees of warming, regions like the UK will face a 10-fold increase in the risk of severe wildfires. It also introduces a lethal biological limit known as a wet bulb temperature. A wet bulb temperature measures heat combined with high humidity, marking the exact physical point where human sweat can no longer evaporate. Without evaporation, the human body cannot cool itself, making natural outdoor survival impossible. This map highlights the physical danger of that limit. If the global average climbs to 2 degrees, 35% of Earth's land area, primarily across equatorial regions, will succumb to these lethal wet bulb conditions, subjecting 1 billion people to uninhabitable heat. If the global average climbs to 4 degrees, that hazard zone expands to cover 60% of the Earth's total landmass. 3.5 billion people, roughly half the global population, would be caught in areas physically too hot and humid to survive. Meanwhile, the complete melting of the Greenland and Antarctic ice sheets would eventually raise global sea levels by 195 feet. That volume of water would swallow 400 million coastal homes worldwide. Passing these physical thresholds triggers a mass extinction event for humanity. The cruelest mathematical reality of this warming is its asymmetry. The populations that contributed the absolute least to the carbon imbalance are suffering earliest and hardest. Nations like Pakistan and Somalia account for barely 1% of global emissions, yet they are currently enduring devastating, supercharged floods and unrelenting multi-year droughts. These extreme shifts have already forced 1.3 million people in Somalia to permanently abandon their farmlands, turning them into climate refugees just to survive. The biological collapse extends all the way down to the foundation of our food chain. Insect populations have plummeted by 75%, a stark indicator of a self-imposed sixth mass extinction. This crisis is fueled by extreme overconsumption. The richest 1% of the global population emits as much planet-heating pollution as 2/3 of all humanity combined. We have the industrial capacity to change the equation by moving away from fossil fuels. The U.S. alone is expected to add 490 gigawatts of new solar energy capacity by 2036. A gigawatt is a unit of power equal to 1 billion watts, enough to power hundreds of thousands of homes. We cannot out-air condition this math. We have to systematically stop fueling this accelerating fire before we cross the final tipping point.